Welcome to Circuit Masterclass, your go-to channel for everything in power systems, transmission, and distribution engineering. Don't forget to check out circuitmasterclass.com for in-depth blogs and bonus content. We have provided the website link below in the description. Let's get started. Here, I will discuss how a very small inductive current, say around 10 or 20 amperes, is interrupted by a circuit breaker. Let us assume that the circuit breaker is rated for interrupting very high short-circuit currents. That means the breaking capacity of this high-voltage circuit breaker is about 25 kiloamperes or even higher, like 31.5 kiloamperes, 40 kiloamperes, or 50 kiloamperes. Now, if we try to interrupt a very small inductive current, say 10 amperes or 20 amperes, using this same circuit breaker, it might not perform efficiently. The reason is that the deionization force, the force that the breaker applies to re-establish the dielectric medium after the arc is formed during contact separation, may behave differently. When the dielectric medium between the contacts breaks down due to arc formation, and the short-circuit current waveform naturally crosses zero, the breaker applies deionization force to quickly re-establish the dielectric strength between the contacts. This ensures that the current does not restrike after zero crossing. That is, the arc does not reignite. This process is applied in high-voltage circuit breakers to break short-circuit currents. The capacity to do this is called the short-circuit breaking capacity of the circuit breaker. But if the current is too small, the breaker may not realize whether the current is large or small, because the same deionization force applied for large currents is also applied for small currents. This leads to a problem. Due to the strong deionization force, the dielectric medium may be re-established well before the natural current zero, and the current may be interrupted prematurely. This yellow curve is the current waveform. If we assume that the circuit is fully inductive, then when the current is chopped before the natural zero crossing, the di per dt, rate of change of current, becomes very high. And since the circuit is inductive, L times di over dt results in a high voltage across the contacts. When the contact is just opened and current continues, the voltage between the contacts is nothing but the arc voltage. At the moment the current is interrupted due to this strong deionization force, a sudden high voltage spike develops between the contacts. This is called the restriking voltage. This is the instant when the circuit breaker starts opening. This is the instant the current was chopped. This is the restriking voltage. Due to this restriking voltage, the dielectric medium, which had been re-established, again breaks down, and the arc starts again. Then the voltage between the contacts again drops to arc voltage. This cycle continues. Even as this cycle continues, the contact gap keeps increasing because the breaker is still opening. Eventually, the distance between the moving and fixed contacts becomes so large that the dielectric medium between them becomes strong enough to prevent further restriking. As a result, the current is finally interrupted. So in this way, a very small inductive current gets interrupted by a circuit breaker that is rated for very high short-circuit current.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment. Thank you.